Evening, dear students. So we are discussing the second chapter, that is structure of atom. Okay. So in the last class, we have seen the questions based on quantum numbers, right? Yes. So we have seen various important this topic, okay, on the chapter structure of atom. Okay, so based on the previous knowledge, okay, so let us solve some questions, some more questions. Okay, fine. So let us start. Okay, so this is the question. The lightest particle is among the following, which is the lightest particle? Okay, that is A electron, B proton, C neutron, and D alpha particle. So these are some of the easy questions. Okay, so these are the basic questions. Okay, so can you tell which is the lightest particle among the following? The lightest particle among the following: A electron, B proton, C neutron, and D alpha particle. Yes. Lightest particle means what? What you have to consider? You have to consider the mass. Okay, we have seen in the synopsis. Do you remember we had seen the tabular? Yes, in the this. Okay, the different mass charge, mass by charge ratio. Okay, different this were given. Okay, so do you remember the mass? So among the following, lightest particle means what? You have to consider the mass, okay, which is lighter in size. Okay, lighter in mass they have asked. So A is electron, B is proton, C is neutron, and D is alpha particle. Okay, so which is the lightest? If we consider the masses, okay, okay, Hema is answering. Yes, please answer. Electron.
Electron.
Okay. Yes, very okay, fine. Her answer is electron. What about others? What about others? So let me write the masses. Okay. So the mass of electron is 9.1 into 10 raised to minus 31 kg. So these things were written in the tabular. Okay. If you have not gone through, even in your textbooks, okay, in the textbook, one tabular is given. In that, the masses are given of these fundamental particles. Okay, mass of the electron is 9.1 into 10 raised to minus 31 kg. Next is mass of proton. Okay, proton is a positive, okay, entity, particle. Then what is the mass of this proton? Yes, it is 1.673 into 10 raised to minus 27 kg. Okay. Then next we will see the mass of neutron. Okay, neutron is what? Neutral entity. Okay, neutral particle. The mass is 1.673 into 10 raised to 675 into 10 raised to minus 27 kg. Okay, and mass of alpha particle. Mass of alpha particle. Okay, it is 6.67 into 10 raised to minus 27 kg. Okay, when you see this charges, okay, when you see the charges here, okay, everywhere you can see 31, this is 27, 27, 27. Okay, when we see a negative number, okay, 27 is a what? It is a more number, okay, as compared to 31. Okay, when you are going on the left hand side, so it is 0, minus 1, minus 2, minus 3. So first 27, okay, then 31st come. Okay, so the lightest entity is what? It is the electron. So A is the answer. Okay, is the answer. So option number A, that is electron. So remember that. So whenever they ask you the lightest particle, you have to consider what? You have to consider the masses. Okay, fine. I hope this is clear. Let us go for the next one. Alpha particles are represented by. How are the alpha particles represented, student? A, helium atom, B, helium, and D, hydrogen atom. How is the uh, how is the alpha particle represented? Alpha particles. What are these alpha particles? Yes, anybody knows what are these alpha particles? How they are represented?
Hydrogen atom.
Okay, Likith has answered as hydrogen atom. What about others? Alpha particles, how they are represented? You can try. If your answers are wrong, no problem, but trying is very important. Okay, we should try. Participation is important. Okay. Alpha particles are represented by A, helium atom, B, helium nuclei, hydrogen nuclei, and hydrogen atom. Okay. What are these alpha particles? First of all, okay. So alpha particles are what? These are the positively charged particle. Okay. Alpha particles, they are represented as what? They are represented as a positive charge. Okay. Positively charged particle. Fine. They are, what does this alpha particle consist of? It consists of, okay, it consists of two proton, okay, two proton and two neutrons. Okay, two protons and two neutrons. So alpha particle, what it consists of? It consists of two protons and two neutrons. Fine. Now, they are, how they are identical? They are identical to a helium atom. Okay, they are identical to helium. That is your He. Okay, He 2 4. So how they are represented? They are represented as alpha. Okay, they are represented how? They are represented as alpha. Fine. So helium, it is represented to helium nuclei. So how is your alpha particle represented to helium nuclei? Helium nuclei, what it consists of? It consists of, okay, 4 plus and 2. Okay, so 4 is the mass and 2 is the atomic number. Fine. So alpha particles, they are the positively charged. It consists of two protons and neutrons. How are neutrons calculated? Mass number minus atomic number will give you what? It will give you the number of neutrons. Okay, and the atomic number itself is your number of protons it represents, right? So it is, sorry, not option number, I have marked is, I have marked it wrong. It is option number B. Okay. Helium nuclei. Option number B. Sorry. Option number B, helium nuclei, because He2 and 4. Okay. So B. B is the answer. So remember that alpha particles are what? They are the, these are positively charged and they consist of two protons and two neutrons. Okay. Let us go for the next one. Easy question. Okay. Neutron is discovered by, how is neutron discovered by? A, Chadwick, B, Rutherford, C, Yukawa, and D, Dalton. Yes. Who discovered neutron? Yes, students, who discovered neutron?
Option B.
Option B. Okay, Rutherford. Fine. Others who try to answer, who has discovered neutron? Neutron is discovered by, yes,
Yes, ma'am. Rutherford.
No, I could not hear. The answer is A. Okay. Neutron was discovered by Sir Chadwick. Okay. Sir James Chadwick. Sir James Chadwick. So he discovered neutrons. Okay. In the year 1932. In the year 1932. So in the synopsis, in the short notes, this one table was there, right? So there we have discussed about this. So neutron is discovered by Sir James Chadwick. Okay. He was a scientist who discovered neutron, which is a neutral entity, neutral particle. Okay, let us go for the next one. The number of neutrons in di-positive zinc ion with mass number 70 is the number of neutrons. So you have to calculate the number of neutrons. Okay, you have to calculate the number of neutrons in di-positive zinc. What do you mean by di-positive, students? Zinc with +2. Di means what? 2. Okay, di represents 2 and positive means +2. Okay, so di-positive means what? +2 charge. So the mass number is given as 70. The mass number is 70 and atomic number is what? Of zinc. What is the zinc atomic number?
Ma'am, answer is 34.
Answer is 34. Okay, fine. Others? Try to answer. Very easy. Last time I have told you how to solve this. What is the atomic number of zinc?
30.
Yes, it is 30. Very good. Okay. So what they've asked to find the number of neutrons. Okay. Now protons, how is proton calculated? Proton is calculated by the atomic number. So number of protons are how many? It is 30. Okay. Then number of electrons. What are number of electrons? Okay. So here the number of electrons are what? -2, because the charge is given as +2 on the zinc. So it is 30 minus 2. It will be 28. Okay. Then number of neutrons. How to calculate number of neutrons? Number of neutrons. Okay. It can be calculated as mass number minus atomic number. What is mass? 70. What is atomic number? 30. So it is how much? It is
40.
40. Okay. So like this you have to calculate. So what is the answer? It is option number D. Okay, it is option number D. So option number D is the answer. So like this. So remember this. Very important. Okay, they will ask you. So how to find the protons? Okay. Protons is how much is the number of, what is the atomic number? That is exactly the number of protons. Okay. Then what is the electrons? Electron is also number as the same number of atomic number, but here there is a +2 charge. Okay, +2 means what? +2 means there is a loss of 2 electrons. Okay, plus means there are loss of 2 electrons. So what we have to do? So we have to minus those 2 electrons from 30. So it is electrons will be 28. Then how to calculate the number of neutrons? Mass number minus the, okay, our answer is option number D. Understood? Okay, our answer is option number D. Okay, let us go for the next one. Nucleons are, now what do you mean by nucleons? Okay, nucleons are A, only neutrons, B, neutrons plus protons, C, neutrons, protons plus electrons, and D, neutrons and electrons. What do you mean by nucleons, students? Anybody knows what is nucleons? What is nucleons?
Neutrons plus protons, ma'am.
Okay, Hema has answered as neutrons plus protons. Okay, so her answer is option number B, neutrons plus protons. Okay, others? What are nucleons? Nucleons are what?
Ma'am, option C.
Option C. Okay, Likita has answered as option C. One answer is B, one answer is C. What about others? Others have no answer. Nucleons. Okay. Chandu has answered it as C. Others? No answer? No answer only for this question. Nucleons are what? Okay. Answer B. Netra has answered as answer B. Now, when you see the okay, in the center, what is present in the center? Okay, now like this. So in the center, what will be present? In the center, the protons will be present, right? So this protons, what it consists of? It consists of protons. So this center part is called as what? This is called as what? This is called as nucleons. Okay, this is consist of what? Nucleons. So here, what is present? Your protons plus neutrons are present. Okay, protons plus neutrons are present, and around this nucleus, okay, what is nucleons? What is present? Your negatively charged electrons. So the electrons are revolving around this. Okay, so in the center, what is present? Your protons as well as the neutrons are present. Okay, neutrons are neutral particle. Okay, so remember that. So what it consists of? Protons plus neutrons. So whoever has answered as option B is the correct answer. That is neutrons plus protons. Okay. So nucleons, what does nucleons consist of? It consists of protons and neutrons. Okay, we have seen the representation, right? In the center, the nucleons is present. In the nucleons, positively charged proton and the neutral particle neutrons are there. Around this, what is present? The electrons are revolving around the nucleus, right? The electrons are revolving around the nucleus, and this is called as what? This is called as the shell, electron shell. Okay, where the electrons will stay. The electrons, they stay in this electron shell. Okay, so they are called as the round. Okay, they are called as electron shell. So in the center, protons and neutrons are present, which is together called as nucleons. So option number B is the answer. Okay, let us go for the next one. Okay, we have a question now. Suppose 10 raised to, so this is a question based on electromagnetic radiation. Okay, we have seen some about electromagnetic radiation, remember? Okay, so let us solve. Suppose 10 raised to minus 17 joules of energy is needed by the interior of human eye to see an object. How many photons of green light, that is lambda is equals to 550 nanometer are needed? These a minimum amount of energy. A 14, B 28, C 39, and D 42. Yes. How you are going to solve this? So this is based on the electromagnetic radiation. Okay, how you are going to solve this? Yes. How many photons? They have asked how many photons of green light is this. Okay, so what all is given here? Energy is given. So we will see what all are given. So given is energy. So energy is 10 raised to minus 17 joules. Okay, energy is 10 raised to minus 17 joules. Then what is given? Then your lambda is given. Okay, lambda is given. Lambda is equals to 550 nanometer. Okay, 550 nanometer. They have asked how many photons is required. Okay, how many photons is required? So according to photoelectric effect, okay, there is one formula, E is equals to h nu. Okay, E is equals to h nu. That is we have seen. Okay, so we require how many photons? So we will introduce here n, small n. Okay, we will introduce what? We will introduce here small n. Okay, so E is equals to n h nu. So now E is equals to, what is nu? Nu is the frequency. Okay, nu is the frequency, which is what? Which is C by lambda. It can, nu is equals to C by lambda. So let us put this value here. So it will be NHC by lambda. Okay, now let us put the values. Okay, E is what? E is the energy, that is 10 raised to minus 17 is equals to, we have to find the N. What is H? H is Planck's constant. The value is 6.624 into 10 raised to minus 24. And C is what? Yes, anybody knows what is C? C is the
3 into 10 to the power 8 meter per second.
Yes, very good. It is what? It is speed of the light. Okay, speed of the light. So which is given as 3 into 10 raised to 8 meter per second. So this is the speed of the light. So C is 3 into 10 raised to 8. Okay, divided by, now lambda value. What we are going to do? We are going to convert this into meter. Okay, so we are converting 550 nanometer into meter. So that will be 550 into 10 raised to minus 9. Okay, so let us put, so 550 into 10 raised to minus 9. So let us put these values. Now we want to find what? How many photons? Okay, that is N. So what we will do, we'll transfer N on the left hand side and we will transfer this side. So after doing the transfer, so it will be N is equals to, okay, so this will come here, so it will be E into lambda. Okay, and H will be, it will become down, so this will become H into C. So accordingly put the values. So E is equals to 10 raised to minus 17 into lambda is 550 into 10 raised to minus 9 divided by H is 6.624 into 10 raised to minus 34. Okay, it is 34, not 24. 34 into 3 into 10 raised to 8. Okay, do the solve the question. Simple calculation, very simple calculation. Solve it and see what you will get the answer. Yes. What is the answer you are getting after solving? Simple calculation. Yes. 550 into 10 raised to 17, 18, 19, 20, 22, 24, 26. So minus 26 divided by 6.2. Very simple calculation. Okay. So 6.624 into 3 is 19. So 19.872 into 10 raised to minus 34 minus 8 is 26 again. Okay, so this is minus and this, so this will get cancelled. Okay, after going this will become plus, so this will become 0. So this will be 0. So do 550 divided by 19.872. I'm getting it as 27.67. 27.67, 27.6. Yes, I can do it. What is the answer? Yes, option number B. So 27.67, okay, which is nearer to 28. Okay, 27.6. If we round off this, it will become 28. So option number B. Understood? Is it clear? Okay, very simple calculation. So just you have to see what all things are given in the question and apply. Okay, fine. So option number B is the answer. Let us go for the next one. The energies E1 and E2 of two radiations. Okay, now here two energies are given, E1 and E2. Okay, so E1 is of two radiation 25 electron volt and E2 is of the radiation 50 electron volt. Okay, now what is the relation between lambda 1 and lambda 2? So they have asked what is the relation between these two. Okay, what is the relation? Now we know that, okay, we know that energy is what? Energy is equals to Hc by lambda. So according to this, okay, according to this formula, what is energy? Energy is inversely proportional to lambda. Okay, energy is what? Inversely proportional to lambda. Right. So now if I put the values, okay, so according to this, so E1 is directly proportional to lambda 1 and E2 is directly proportional to lambda 2. So after substituting 1 and 2, okay, after combining 1 and 2, what I'll get? E1 by E2 is equals to lambda 2 by lambda 1, right? E1 by E2 is equals to lambda 1 by lambda 2 by lambda 1 by combining. After combining 1 and 2, after combining 1 and 2, I am going to get this E1 by E2 is equals to lambda 2 by lambda 1. Put the values. E1 is what? 25. Okay. And E2 is what? 50 is equals to lambda 2 by lambda 1. Okay. So this is 25 ones are 25 twos are. So it is what? 1 by 2 is equals to lambda 2 by lambda 1. So lambda 1 is what? 2
Option
times.
C.
Yes. Lambda 1 is 2 times lambda 2. So option number C. Option number C. Okay. Option number C is the answer. Is it clear? Is it clear now? Hema has answered it as option A. Did you understand, Hema, now? Answer is option number C. How it came. Okay. Yes. Okay. So it's very simple. So just remember the basic. Okay. What formula we have learned. So and apply. So we, according to the formula, we have studied that E is equals to Hc by lambda. Okay. We know that energy is inversely proportional to lambda. Okay. That is wavelength. So after we know that, so what we do? So they have said that E1 and E2, they are the two radiation. They are given the value also. Now they have asked what is the relation between the wavelength, that is lambda 1 and lambda 2. So according to that, E1 is inversely proportional to lambda 1, E2 is inversely proportional to lambda 2. After combining 1 and 2, what we are going to get? We are going to get this. Okay. That is E1 by E2 is equals to lambda 2 by lambda 1. Okay. And finally, we got this. Okay. That is lambda 1 is 2 times lambda 2. So option number C. Is it clear? So it is option number C. Fine. So very simple. Okay. But we need to remember the formula. Fine. Next question. A wavelength 4 into 10 raised to minus 7 meter strikes a metal surface which has a work function 2.13 electron volt. Kinetic energy of the emitted electron is. So here they have asked to calculate the kinetic energy of an emitted electron. Okay. Now we there is something called as photoelectric effect. Okay, there is something called as photoelectric effect. What is this photoelectric effect? So a metal will be there, okay, and the beam of light, okay, beam of light is made to strike, okay, it will hit where the beam of light, a beam of light, what is done? It will strike the metal surface. When it strikes the metal surface, some of the electrons, okay, some of the electrons are ejected out, okay, they are ejected out, and this effect is called as photoelectric effect. Okay, you are going to study in detail in your theory. So I have just given you a small description, very important concept, that is photoelectric effect. So a beam of light, what they are doing, they are striking on a metal surface. You know what is a metal, okay? So they make two strike. Strike means what? They hit it on the beam of light. It falls on the metal surface. When it falls on this metal surface, some of the electrons are ejected out. Ejected means what? They come out of the metal surface, okay? And this effect is called as the photoelectric effect. So just simple, okay? Now here for photoelectric effect, for calculating the kinetic energy of a work function, okay, we know that energy is equals to h nu. So h nu is equals to h nu naught plus kinetic energy. So this is the formula, okay? Now what all is given? Wavelength is given. So what all is the given? So from this given is wavelength, that is 4 into 10 raised to minus 7 meter. Okay. Then what is given? Work function is given. That is H mu naught. Okay. H mu naught is the work function. That is 2.13 electron volt. Now, from the photoelectric effect, we have this formula, that is H nu is equals to H nu naught plus kinetic energy. So let us put the values. Okay. What is H nu? H nu is Hc by lambda. H nu is Hc by lambda. Okay. So that is equals to H nu naught plus kinetic energy. Now, put the values now. H, we know the value 6.626 into 10 raised to minus 34. C is 3 into 10 raised to 8. Okay. What is lambda? Lambda is 4 into 10 raised to minus 7. Then, what is work function? Work function is 2.13. Electron volt. Okay. Electron volt. What is the value of one electron? It is 1.609 into 10 raised to 19. Okay, we have to put the value of electron volt, that is 1.609 into 10 raised to minus 19 plus kinetic energy. Okay, now what we have to find? We have to find this kinetic energy. Now let us transfer this kinetic energy on the other side, left hand side. Okay, solve this. 6.626 into 10 raised to minus 34 into, do that on the left hand side, whatever is there, 6.626, okay, into 3 is again 19.878 into 10 raised to 34 minus 8 is 26. So minus 26 divided by 4 into 10 raised to 7. So now 19.878 divided by 4 is what? I'll erase this. Okay, so I'll directly write it. So it is 4.9695 into 10 raised to minus 34 into 10 raised to 7. So minus 34 minus 7 is 27. So this will become 27. Okay, minus 27 is equals to, okay, is equals to now 23 2. Minus 2.13 into, I'll just multiply it, 2.13 into 1.609, that is 3.427 into 10 raised to minus 19. Okay, do this simple calculation. So 4.9695 minus 3.427. Okay, and 10 raised to 27 plus 19. 46 here only somewhere. 7, 37, 34 minus 8 is 26. 26 minus 26 minus 26 minus 7. Okay. Here it becomes minus 26. No. First it will become minus 26. Okay. Here it will become 10 raised to minus 34 and plus 8. This is 10 raised to minus 26. Okay. And this after transferring, this will become plus 7. So 26 minus 7 will be 19. So this is 10 raised to 19. Yes, 10 raised to 19. So 10 raised to minus 19 is common. Now you do. So 4.9. Okay, 9695 minus 3.427. I am getting 1.54 into 10 raised to minus 19. Everybody got the same? Option number D?
Yes, ma'am.
Okay, fine. So option number D is the answer. Okay, so like this. So remember this formula of work function. If they ask you to find out the kinetic energy with respect to photoelectric effect, Okay, then you have to remember this formula. H nu is equals to H nu naught. What is H nu naught? This is a work function. Okay, and they will ask you to find out the kinetic energy. Okay, we need to know the values and do the correct substitution. Okay, now just see how we got confused here. No, in the no, this. Okay, so like this. So each step you have to do it properly. So I have got the option number D. So 1.5 into 10 raised to minus 19 joules is the answer. I hope you have got it. Okay, let us go for the next one. So next is line spectrum. Okay, we have studied about the quantum numbers. So another important concept what you are going to study in the theory is line spectrum of hydrogen. So directly I am going to tell you the formula which has to be remembered. Okay, so for line spectrum of hydrogen, the what is important is the wave number. This is the wave number, that is mu bar, and the wavelength. Okay, so what we are going to do, we are going to calculate the different series of lines. Okay, and these different series of line, it is given by this formula. So if you want to calculate the mu bar, so mu bar is equals to 1 by lambda, which is equal to r into 1 by n1 square minus 1 by n2 square. So lines of hydrogen spectra, it can be given by mu bar or it can be given by lambda. If they ask you mu bar, then it will be r into 1 by n1 square minus 1 by n2 square. If they ask you lambda, it will be 1 by lambda. 1 by lambda is equals to 1 by n1 square minus 1 by n2 square. So remember this formula, and what this is r, this is the Rydberg's constant. Okay, this is the Rydberg's constant whose value is 1.09677 into 10 raised to 7 per meter. So remember, okay, line spectrum. I'll show you the line spectrum. So these are the different lines. What is that N1 and N2? You can see this N1 and N2 here in the formula N1 and N2. Okay, now we will study what is this N1 and N2. So these are the different spectral lines. So in the hydrogen line spectrum, there are mainly, okay, there are mainly 5. So here you can see here, yes. So there are 5 different series of lines. Okay, there are 5 different series of line. The first line series, it starts from n is equals to 1. Okay, when n is equals to 1, okay, and n that is n1 and n2 can be your from 2, 3, 4 like that. This is called as Lyman series. Okay, this is called as Lyman series, and it falls in UV region. Where it falls in UV region, the first series. Okay, so your n1 will be 1 only, and n2 will be till infinity. From n2 is equals to from 2 to infinity. Okay, so this is our what? This is our Lyman series. Okay, Lyman series you can see here. So Lyman series, it falls in which region? Ultraviolet region, where n1 is 1 and n2 is 2, 3, 4 till infinity. Okay, remember this, very important. Second series is Balmer series. Second series is what? Balmer. These names, Lyman, Balmer, Passion, these are given by different scientists based on their names. Okay, second, Balmer, okay, he found out this series and he gave the name Balmer series, where n1 is equals to 2 and n2 will be 3, 4 to infinity. So here you can see n is equals to n1 is equals to 2, and the rest all lines n2 will be 3, 4, 5, 6, 7 till infinity. Okay, so that is your Balmer series. Where does Balmer series fall? The Balmer series falls in visible region. Okay, it falls in which region? It falls in visible region. Then the third series is Passion series. Third series is what? Passion series, where n1 is equals to 3. n1 is equals to 3 and n2 is equals to 4, 5, 6 till infinity. Okay, that is your Passion series. Then the fourth, this falls in what? This falls in infrared region. Okay, infrared, IR region. Next is bracket series. Next is what? Bracket series, Where does this bracket series fall? It also falls in infrared region, IR, okay, where N1 is equals to 4 and N2 is equals to 5, 6, 7 till infinity. Okay, this is the fourth one. Then the fifth one is the P fund series. Okay, P fund series. This also falls in the IR region, okay, infrared region, where N1 is equals to 5 and N2 is equals to 6, 7 till infinity. Okay, so remember this hydrogen line spectrum. Okay, very important. And remember the series also. Okay, for Lyman, where it starts, what is N1, N2, for Balmer, for Passion, for bracket, and for P fund. So remember what is N1, what is N2. If you know, remember the series, and Lyman starts from N1 is equals to 1. Okay, then N2 will be from 2, 3, 4, like that. Balmer starts from N1 is equals to 2. So N2 will be 3, 4, 5 till infinity. Then is Passion series, N1 is equals to 3. So N2 will be 4, 5, 6. Okay. Then bracket series, N1 is equals to 4. So N2 will be 5, 6, 7. Okay. Then P fund series. Okay. N1 is equals to 5. So N2 will be 6, 7, 8 till infinity. So remember this, very important. So this where it will be important for questions. Okay. When questions will be asked. Fine. Let us solve, then we will go for this. Okay. In Bohr series of line, okay, just now we have shown the line spectrum, no, on that it is. In Bohr series of lines of hydrogen spectrum, the third line from the red end, corresponds to which of the following inter-orbit jumps of the electron for Bohr's orbit in an atom of the hydrogen. Okay, now we need to, what we have said is, studied, Lyman series falls in UV region, Balmer series falls in visible region. Okay, then is our Passion series, then bracket series. Okay, then is our P fund series. So these all fall in IR region. Red color. Okay, red color means it falls in what? It will fall in the Balmer series. Okay, so Balmer series. So it falls in what? It falls in Balmer series. So in Balmer series, what is N1 and what is N2? Can anybody tell me? N1 will be 2.
2, ma'am.
Yes, N1 will be 2. And what is N3, N2? 3, 4 to infinity. So can you tell me now, based on this, which is the, so what they have asked, so from the red line, okay, means from the Balmer series, it has jumped to the third line, means N1 is 2. So what is N2? Third line is what then? After third line is what? 3, 4 and
5, ma'am.
5. So our N2 is 5. Okay, so the inter-orbit jump is from what? It is from 5 to N1, that is N1 is equals to 2 to 5. So that is 5 to 2. Okay, option number A. Option number A is the answer. Okay, so understood? Okay, so like this you have to remember. Okay, so like this the series are important. Okay, so the series is important. So you have to remember the series. Very important. Okay, let us go for the next one. Similar. Now here they have asked the wavelength. So the wavelength Yes. Let us continue. So here they have asked the wavelength. Okay, so wavelength of a radiation emitted when in a hydrogen atom electron falls infinity to stationary state 1 would be, what would it would be? What will be the wavelength? Okay, what is the formula? 1 by lambda is equals to R. Okay, 1 by n1 square minus 1 by n2 square. So this is the formula. What is Rydberg's constant value? It is 1.097 into 10 raised to 7. Right. Now, let us put what they have asked. The wavelength of the radiation emitted when in a hydrogen atom electron falls infinity to stationary 1. So, what is our N1? What is our N2? Can anybody tell me? What is our N1? What is our N2? They have said the hydrogen electron, it is falling from infinity to stationary state 1. So can anybody tell me what is N1 and N2?
N1 is 1, ma'am. N2 is 2 to infinity.
Yes, it is infinity because I have directly told, right? Infinity. It is falling from infinity to 1. So our N2 is infinity, N1 is 1. So let us put the values and find out. So 1 by 1 square minus 1 by infinity square. Okay. Then so it is what? So 1.097 into 10 raised to 7 per meter. Okay. So 1 by infinity. So this is 1 by lambda. Now we have to find what? We have to find what is lambda. So this is 1 by 1 square is 1 only. And 1 by lambda, this is infinity. So this will become 0. Okay. This will become 0. So now what is lambda? So what we have to do? We have to go just this. Okay. 1 by lambda. So 1 by 1.7 divided by 1. So lambda will be, so I'll do reciprocal of that. Okay, if I take reciprocal of that, so if I transfer, okay, 1 this side, so it will be 9.1 into 10 raised to, okay, 9.1 into 10 raised to minus 8 meter. Okay, so that is nothing but 91 nanometer. So that is 91 nanometer. So option number D. So I'm getting the answer as D. Okay, so I'll take the reciprocal of this. Okay, 1 by lambda. I want wavelength. So I'll just take reciprocal. So it will become, so I'm shifting 1 decimal that side. Okay, 2 decimals. So it will be 1.097. So that has become 9.1 into 10 raised to minus 8 meter. That is 91 nanometer. So option number D. Okay, option number D, no, option number C. Option number C is the answer. Okay, 91 nanometer. No, so it is option number C is the answer. Fine. So how I have got that here? 1 by 1 square minus 1 by infinity square. This is 1.097 into 10 raised to 7. Okay. So what we have done? So this into this, it will be so 1 by lambda. So or I'll do, so what I'm doing? So lambda is equals to, okay, 1 by 1.097 into 10 raised to 7 per meter. Okay, because we want to find the lambda here. Okay, we want to find the lambda. So this will be what? Now you see, now, so 1 divided by 1.097. Yes, so I got 0.91. Okay, 91 into 10 raised to minus 7 because this is 7. So when it goes above, it will be minus 7 meter. So I'll transfer, it will become 91 into 10 raised to, if I, this will be 9. So it is 91 nanometer. So option number C. Understood now? Now I hope it is clear. Okay. Yes. So okay. When the electron of a hydrogen atom jumps from n is equals to 4 to n is equals to 1 state, the number of spectral lines emitted is. Yes, how you are going to answer this? A 15, B 9, C 6, and D 3. When the electron hydrogen atom jumps from n is equals to 4 to n is equals to 1. So electron is jumping from what? Electron is jumping from n is equals to 4 to n is equals to 1. Okay, ground state, that is ground state is your n is equals to 1. Okay, so that time how you have to calculate, there is a formula to calculate the number of spectral lines. So please write it down. Write this formula to calculate the number of spectral lines, that is n is equals to n minus 1 by 2 to calculate the spectral line. Okay, so the electron is jumping from which level? From n is equals to 4 to 1. Okay, so put n is equals to 4 in this formula. So 4 into 4 minus 1 by 2. So that is 4 into 3 by 2. So it is 12 by 2. So it is 6. So the number of spectral lines is 6. Okay, so option number C. Option number C. So electron is jumping from, so n is equals to 3, n is equals to 2, n is equals to 1. Okay, so electron jumps from 4 to 3, 3 to 2 to, okay, like this. So the hydrogen electron is jumping from 4 to, it can jump from 4 to 3, 4 to 2, okay, 4 to 1. Fine. So like this, it will form 6 spectral lines. Okay, so option number C is the answer. I hope you are getting it. Yes? Fine. This we have seen, the dual behavior, this formula we have seen. Okay. Okay. Heisenberg, there is something called as Heisenberg uncertainty principle. So according to Heisenberg uncertainty principle, it states that it is impossible to predict both the position and momentum of an electron simultaneously. Okay. So the formula is what? For that, to calculate, we cannot predict. Okay. We cannot find out the position and the momentum of a electron. So the formula is delta x, okay, into delta p is greater or equal to h by 4 pi. What is p? P is the momentum which is given by mass into velocity. What is delta x? It is the uncertainty in position. Delta p is what? It is the uncertainty in momentum. Okay, and so it is given as what? So this is the Heisenberg uncertainty principle. So based on that, let us solve one problem on Heisenberg uncertainty principle. Uncertainty in position of a minute particle of mass 25 grams. Okay, so this is there. Okay, particle is there which is of the mass what? 25 grams. So mass is given. What is the mass? 25 grams. In space is 10 raised to minus 5 meter. So the uncertainty position is delta x, which is given by 10 raised to minus 5 meter. Okay, the uncertainty in its velocity has to be find out. So, and h is given, what is 6.6 into 10 raised to minus 34 joule second. So I'll give you the formula. So delta x is into delta, that is m into delta v. Okay, m into delta v greater or equal to h by 4 pi. Put the values now. Put the values. What is delta x? The uncertainty in principle. What is the value? 10 raised to minus 5 into mass is 25. Okay, into what is the change in velocity? This your velocity we don't know. Okay, so we will keep it like this. So mass is given as 25 into 10 raised to minus 3. Okay, into delta V that we don't know. It greater or equal to h value is 6.6 into 10 raised to minus 34. 4 into, what is pi value? Pi value is 3.14.
1.
Yes. Now do it. Now do the calculation. Let us take delta V here and put the remaining value this side. So it will be 6.6 into 10 raised to minus 34. Okay, divided by 4 into 3.14 into 25 into 10 raised to minus 3 kg. So we have converted the mass, okay, gram to kg. So because of that, we have into 10 raised to minus 3 into 10 raised to minus 5 meter. Okay, this meter. So do this and see what answer you are getting. So 4 into 3.14 into 25, and this is 314 into 10 raised to minus 8. Okay, and this is 6.6 into 10 raised to minus 34. So 6.6 divided by 314, it is 0.021, and after transferring this will become plus, so it is 34 minus 8, it is 26, minus 26. So here it is meter and up is meter per second. So answer is, if I transfer this here, it will be 2.1, okay, and into 10 raised to minus 28. So if I, yes, if I transfer this by 2 decimal, it will be 28. So meter per second. So our velocity is 2.1 into 10 raised to minus 28. So option number C. Option number C. Everybody got the same. So remember the formula, okay, for uncertainty, Heisenberg principle, very important. Okay, a question asked for theory also, 2 marks question. What is Heisenberg uncertainty principle? Okay, one more question. Uncertainty in the position of an electron. Okay, mass is given of the electron, which is 9.1 into 10 raised to minus 31 kg, moving with the velocity of 300 meter per second. Okay, and there is some accuracy. Accuracy is given of 0.01%. So what is the, they have asked, okay, what will be the uncertainty in the position? They have asked, accuracy is given. So we have to find the change in velocity. Okay, change in velocity. Let us put this values. Let us put this values. So what is the change in velocity? Change in velocity is, accuracy is 0.1 divided by 100. 0.1% means what? Percentage divided by 100 into 300. Okay, so this is the change in accuracy what we are going to get. So it is 3 into 10 raised to minus 3 meter per second. Okay, so this is the value we are going to get. That is the uncertainty in the velocity. Okay, so accuracy is given. So by putting the accuracy with the velocity, we are going to find the change in velocity. So that is 3 into 10 raised to minus 3 meter per second. Okay, now let us put the formula, that is delta x into m delta v greater or equal to h by 4 pi. Okay, h by 4 pi. H by 4 pi. Put the values. So we have to find what? Delta x. So let us take delta x here on the, and shift this everything on the other side. Okay, h by 4 pi. Okay, h by 4 pi into m delta v. So put the values now. Delta x is equals to, h is 6.6 into 10 raised to minus 34. Okay, kg meter square per second. This is the value. Next, 4 into 3.14 into mass is 9.1 into 10 raised to minus 31 kg into, next is what? Change in this, that is 3 into 10 raised to minus 33 meter per second. Yes, now do. I have put all the values. Okay, kg get cancels here, meter square get cancels. second get cancels. So delta x will be, so do the calculation, simple calculation, 4 into 3.14, 4 into 3.14 into 9.1 into 3 is 342.888 into then 10 raised to minus 31, 32, 33, 34. So this is 10 raised to minus 34. What remains here? 30. Yes, find out what you are getting. Just see.
5.7.
Just let us see. 6.6. So 6.6 will forget the this. Okay, just 6.6 divided by 342.888. I am getting it as 0.0192. So here only the answer is okay. Option number A or B. A or B. So this is into 10 raised to 3. So if I shift the decimal, okay, by this side, so it becomes 1.92 into 10 raised to minus 2 meters. So answer should be option number C. Write down this, okay, and try. You have to get the answer as C, option number C. Option number C, okay. Fine. So rest all things we have seen, quantum numbers and all things, okay. Yes, so by this we have completed the chapter structure of atom. Okay, in the next class we are going to start with the new chapter. Fine. Okay, so these were some of the important. So this particular chapter is very important. Okay, it has a good number of weightage for KCET. Because there are different concepts. Quantum numbers is there, photoelectric effect is there, okay, your hydrogen line spectrum is there, okay, Heisenberg uncertainty principle is there. So many concepts are there here, from easier to very hard level. So please focus on this particular chapter. So this will fetch good number of marks. Okay. So by this, I would like to end the session here. Okay. So we'll start with the new chapter in the next class. Thank you.